Hello, welcome to your third lesson on organic chemistry. So today we're going to start off looking at something that might be a little bit sensitive. So below you can see 4 pictures of Grenfell Tower. In 2017, the tower caught alight and very quickly went up in flames. Now, part of the risk assessment for fires in the tower, residents were told that they should remain in their flats and that they would be fine if they did this. Those, unfortunately, that did follow that advice did not necessarily survive. The tower had cladding put on the outside, which helped the fire to rise up very quickly, as you can see, and engulf the tower in flames. So the first thing I would like you to do is have a think. What are the tips you would give someone if you were in a fire? And why would you do that? So today's title is Combustion of Hydrocarbons. If you've got your revision guides, it's page 150 for Trilogy and page 75 for the separate chemistry revision guide. So if we were in school, we would be doing a demo looking at proving the products of combustion of methane. This is what comes out of our gas taps at school and would come out of any gas taps at home if you've got a gas oven. So watch the video and make a couple of notes as to what the proof is of the products of the combustion of methane. So from the video, we should now know that methane reacts with oxygen that is in the air and creates carbon dioxide and water. This is called complete combustion because there's plenty of oxygen there and we produce carbon dioxide. Using the information from the video, I'd like you to match up the chemicals, oxygen, carbon dioxide and water to the lab test as listed below. So ethane is the second alkane, C2H6. It also reacts with oxygen to produce carbon dioxide and water. In red we have our balanced chemical equation. Now remember, when you balance equations, you can only put big numbers in front of any formulas. You cannot change the formula of any other substance. So your next task for today's lesson is to have a go writing down the word equations for the complete combustion of propane and butane. And if you're confident and want to have a go, write down the balanced chemical equations for both the complete combustion of propane and butane. Now we're going to have a look at incomplete combustion. So this is where we have a lack of oxygen present. So methane will react with oxygen to produce carbon monoxide and water. So mono means one, so that carbon it's only bonded to one oxygen. Now this becomes an issue because to us, carbon monoxide is colourless, it is odourless, and most importantly, it is toxic. So it reacts and binds with the hemoglobin in your red blood cells and stops oxygen travelling around your body to cells for respiration. So obviously if this was to happen, we would drift off to sleep and not wake up. Ethane also reacts with oxygen to produce carbon monoxide and water. Remember, this is incomplete combustion. So similar to the previous task, I would like you to have a go at the word equations for the incomplete combustion of the above alkanes, propane and butane, and have a go at writing down the balanced chemical equations. I know some of you find these tricky, but practice does make perfect. Your final task for today is to look at all those statements below. Have a go at putting them into 2 groups, one of complete combustion statements and one for incomplete combustion statements.